Hi dear children, as you know in our previous classes in the 9th standard, the second chapter polynomial, in which we studied the basic definitions as well as kinds of the polynomial and exercise problems, that is 2.1 and 2.2. And today we are going to discuss about the remainder theorem. Yes, firstly you can remember what do you mean by remainder theorem. So before going to that, you know that there are so many methods to find the factors, in which division is also one of the major kind of the theorem. So today in this class we are going to discuss stepwise remainder theorem. So let us start. Look here, polynomial remainder theorem, in which the process of division. Yes, you know that the division can be done by our traditional method, that is division. So it is called as long division. What are the process involved in this long division process? That I written over here. So look here. First, take the first step number 1. It says as we write the dividend and divisor in standard form. Any number, any polynomial, if you consider their standard form. Of course, it is applicable for especially polynomials. Number may be any real number also. So we write the dividend and divisor in standard form first. So that is arranging the terms in descending order of their degrees. Here degrees also required. For example, 1 plus x square, it can be written as x square plus 1. The same way, step number 2, after the first step, second step, we divide the first term of the dividend. First term of the dividend can be divided by the first term of the divisor. So in which first term of the dividend can be divided by the first term of the divisor. So second, that is one. Now third step number 3, we multiply the divisor. We can multiply the divisor by the first term. We multiply the divisor by the first term of the quotient and subtract the product from the dividend. It shows us, if you multiply, what you can multiply? Divisor of the first term and quotient of the first term can be multiplied when you are going to division process. In the third step, we do first term of the divisor and the first term of the quotient can be multiplied. So their product should be subtract to the dividend. What is the entire dividend? The first step, we treat the remainder. Now after product, when you get the subtract, some new remainder came, so we treat the new remainder as the new dividend. Just now remainder came in the first step. That first step remainder goes to the next step. Then in the next step it will become the new dividend. The divisor remains the same. Means divisor is always same. Now come to the next step here. Step number 5, in which after 4 step, 5th step, we multiply the divisor by the second term now. Multiply the divisor by the second term of the quotient. No second term of quotient came. And subtract the product from the dividend. Same process. So this process will continue. The same way, this process will continue up to the remainder comes to the 0. Means this process continues till the remainder 0 or degree of the new dividend. Degree of the new dividend means it is a remainder is less than the degree of the divisor. Hence, the last step, when you obtain like this remainder as a 0 or less than the divisor of the degree, so then the step number 6, if you want to confirm it, once again check it, you can check it, that is by verifying the result. By this power statement, that is dividend is equal to divisor into quotient plus remainder. So dear children, these are the entire process to understand the how to division will occur in the given polynomials. Any polynomials, okay, whether it is binomial, trinomial or any polynomial. One polynomial can divide the other polynomial, means it will follows the same process or steps. So this is one. Now I will take the example also. Now take one example related to this remainder theorem. Okay, and afterwards I will come to the general form. So in a polynomial, consider any polynomials. Two polynomials are given here. One is polynomial and another one is trinomial. Consider it is a p of x and it is g of x. Okay. So here they given divide this one. How we can divide? By long division process. Just now I shown the process or steps. According to that we can do. So by long division. Okay, method. By long division. Consider here one of the divisor, one of the polynomial has divided. So always which is the highest degree? 30. Means which polynomial is highest degree? So here x square. Here x to the power of 1. So automatically this become p of x is equal to 3x square plus x minus 1. And next one is consider g of x. Consider p means any polynomial with variable x. G means another polynomial with variable x. Consider it is a dividend and it is a divisor. So by process should write like this: 3x square plus x minus 1. Okay. So here consider here what we have to write this one as divisor. This is divisor, dividend, and here quotient. Remainder should be here. Now according to the square. Okay. So I will write here. So first term here it is. First term of the divisor and first term of the quotient. Which one you want to take? In order to eliminating the first term of the dividend. So that is why you can take 3 here. Here you can multiply with 3. And as well as x square here only x, we should require another x. So if you multiply this one and the first term of the divisor, first term of the quotient and the first term of the divisor, automatically you will get the equivalent value of the dividend of the first term. So next term. Multiply the same term to the whole divisor. Plus into plus is plus, 3x into 1 the 3x. Now what we can do according to second step? Subtract the product. This is the product came over here. You should subtract this from the given polynomial. That is, it become minus and it become minus. So here it is cancelled out. So x minus 3x. What happened? Minus 2x. What is the remainder? Minus 1. Now just now came now. This is called remainder. This is become the new divided. Sorry, new. This one divided. Yes, new. It is new divided. Now consider the second term of the quotient. This quotient of the second term is multiplied to the product of the divisor. This second term of the quotient should be multiplied to the divisor. This product should be equivalent to this new remainder or less than the new remainder or new dividend. So that is why this is number step number 4. So here minus is here, you can take minus because minus into plus is minus. And 2x here, only x here, you can multiply with 2. So 2 minus plus into minus is minus. 2 into x is 2x. Plus into minus is minus. 2 ones are 2. So on subtraction. Remember here, after the product you written here before the dividend, automatically these signs are changes. Positive become negative, positive become negative, negative become positive, negative become positive. So this is on subtraction. For any equations or polynomials, when you going to subtract one to another or one another, then the second polynomial goes to changes its sign. So that is why called subtraction. Now this is cancelled out. Here it is 1 remainder. What is the remainder now? 1. So answer on dividing 3x square plus x minus 1 by x plus 1, you will get 1. So this is required answer. Now take another one example. Now take the second example. I already written. Find the remainder obtained on dividing. Find the remainder obtained on dividing p of x equal to x cube plus 1 by x plus 1. So here solution for this one. So you know that already by long division. By long division. Okay. So by long division, already polynomial can be written in the form of p of x. Consider the standard form, already it is in standard form. So that is why p of x is equal to x cube plus 1. So second one, consider g of x. So that is why it is x plus 1. Standard form, arranged in descending order. Means highest degree, lowest degree, highest degree, lowest degree. Same, which is greater here? P of x is greater than g of x. So that by process what happened, x cube plus 1. And it is x plus 1 and it is quotient. Now the second step, take the first term of the quotient and the first term of the divisor. their product should be equivalent to the first term of the divided. That is, it will become x cube. Multiply this first term of the quotient to the entire divisor, not only for first term. So process will continue. X square plus 1 is plus x square. So now on subtract, okay, minus. Okay, it become minus and it become also minus. Now what happened? This one is cancelled. It is 1 minus x square. 1 minus x square. Now in order to eliminate, the first we want to take what? Minus x square. So here I want to write like this, because I said already in the first step, always the dividend or divisor, whatever it may be, they should be in standard form. Consider here, now new remainder came up, you consider this new remainder as new dividend for the next process. But here 1 is constant number, it cannot be easily divisible by this divisor. Means constant and here variable should not match. So in order to avoid that, take the variables of the degrees in standard form. Here x square is here, minus x square plus 1 as it is written. I written the same equation like this only. So no disturbance. Now consider the first term is x square, means here take minus. Here already x is here, you want to require another one x. Therefore x into plus into minus, minus. X into x is x square. Plus into minus, minus. 1 into x into 1 is x. Now subtract. So here for subtraction, carefully you can subtract. So this is, consider this sign only. It is plus and it is also become plus, because opposite of this signs become plus. It is minus and it is minus. Now this plus x square minus x square cancel, and it is plus x plus 1. So x plus 1 is. So now it is equal to this one. So therefore consider here p of x is x cube plus 1, g of x is x plus 1, and your quotient q of x is equal to x square minus x, and your remainder consider r of x, it should be as x plus 1. So for verification, consider p of x, okay, it's divided, it is equal to, in generally I want to conclude it, p of x into g of x plus divided means into divided q of x plus remainder r of x. So that is p of x means x cube minus x equal to g of x means here x plus 1, here it is x plus 1 plus remainder x plus 1. Here g, what are the quotient is x square minus x. X square minus x. That is okay. I want to repeat, x square minus x. Suppose you can multiply, you will get the right hand side equal to left hand side. So here x is x cube, okay, x cube minus x square plus x square minus x plus 1. Look here, plus x square minus x square plus x minus x cancel. So what is the remainder? X cube plus 1. Your polynomial is also x cube plus 1. Here it is x cube plus 1. Okay, here it is x cube plus 1. Here x cube plus 1 it is. X cube plus 1, x cube plus 1. Sorry, I took as qx, it is not qx, it is p of x. X cube plus 1, x cube plus 1. Therefore, the final answer is x cube plus 1. Means your left hand side and right hand side both are same. It means it is verified. Here all the 6 steps are used according to the division process. We should follow the long division process. Continue. Now consider, based upon these 2 examples along with the steps just now you just observed, and as well as see what happen its general form. So what are these p of x, g of x, q? Yes, in general, let p of x and q of x are any two polynomials so in which p of x is greater than or equal to consider g of x, because same terms can be used. So p of x, g of x means any two polynomials. Here p of x is greater than g of x, that is to find q of x and r of x. Means from the two polynomials in which highest degree of the one polynomial is greater than or equal to second polynomial, these two polynomials can help out to find q of x and r of x, in which g of x is not equal to 0, such that the statement become p of x equal to g of x into q of x plus r of x. So this is our required statement. Here r of x equal to 0. If r of x equal to 0, or then r of x means degree of r of x is greater than the, means less than the degree of divisor. Degree of g of x. Degree of g of x means degree of divisor is greater than the degree of the remainder. So this should be compared. Based upon this, so we can check and verify the result through this general formulas. This is the general form of how to check the division of a polynomial. Consider any polynomial p of x and g of x. So these two are the polynomials. In order to finding the values of q and r of x, q of x and r of x, so your g of x is not equal to 0, then it becomes the general form is p of g of x into q of x plus r of x. So here r of x is not equal to 0. Degree of the r of x is always less than the degree of the g of x. So this is the condition applied. Based upon this, we can solve some more examples and exercise problems. Now we can take exercise problem 2.1. So based upon this remainder theorem, find the remainder when x cube plus 3x square plus 3x plus 1 is divided by these terms x plus 1, x minus 1 by 2, x fourth one x plus 5, x plus 5. 5 is a real number. 5 plus 2x. 5 polynomials are given. These 5 polynomials can divide this term. So we have to check it. And what is the remainder? And here find the remainder. Second main example. Find the remainder when x cube minus x square plus 6x minus a is divided by x minus a. We have to check it. And the third one, check whether 7 plus 3x is a factor of 3x cube plus 7x. Now let us start one by one. So take here solution. For solution, I would like to take any two of the first main. In the first main, so let p of x always, let p of x is equal to x cube plus 3x square plus 3x plus 1. Okay, and take the second one immediately, because first one is easy as comparing to previous example. You can do it. Second one, I want to take x minus 1 by 2. Now consider this as g of x is equal to x minus 1 by 2. Then we know that by long division process. Okay, so consider here p of x may be divided. Okay, x cube plus 3x square plus 3x plus 1, and your divisor is x minus of, means x minus 1 by 2. So this is divisor. Now, so according to steps, these are all in standard form. Of course, this is in standard form, this is also standard form. The second process, you can step. The second step, first consider the first quotient, first term of the quotient and the first term of the divisor. Automatically multiply, that will be equivalent to this one. Here it is the first term of the divisor is x cube. So in order to avoid this one or eliminating this one, take here x square. So x square plus x into x cube. X square into x is x square. Minus, because minus here plus here. Minus into plus minus. X square into half means it is x square by 2. Means 1 by 2 into x square is x square by 2. So now subtract. On subtraction, all signs should be changes. So here it becomes cancelled out. So remaining 3. X square common. So here it becomes 3 plus 1 by 2 x square, and the next term is 3x. Consider here x square is common, take common. 3 plus 1 by 2. So we have to check it. 3 2s are 6 plus 1, 7 by 2 x square plus. Just now I simplified these terms only. The coefficient of this x square can be simplified and the coefficient now becomes 7 by 2 x square plus x. Now take continue the process. Now it is a new divider. So in order to avoid this one, you can take 7 by 2. One x is here, take another one x. The product of this second term of the quotient and the product of this divisor, the whole divisor into second term of the quotient is equal to this one. Check now. 7 by 2 x into x is 7 by 2 x square, because x into x is x square, plus into minus is minus 7 by 2 into 1 by 2. Okay, 7 by 2 x into 1 by 2. So here it becomes 7 by 4x. So here it is 7 by 4x. Okay, 7 by 4. How it is? 7 by 2 into 7 to 1 is 7, 2 2s are 4, x is same. Now you can change the sign. So it becomes changes. Now this first term is eliminating. Now consider x term is common. So plus 3 here and 3 plus 7 by 4 here. Okay, 3 plus 7 by 4 here. So on taking LCM, okay. So 4 is in the denominator. 4 3s are 12. 12. Okay. 4 3s are 12. 12 plus 7, 19. 19 by 4x. So last one term is plus 1. So now continue the process. 19 by 4x plus 1 is the new remainder. Okay. So this is a new, consider this is a new dividend plus 1. So here 19 by 4. Take 19 by 4. Okay. X is already here. Therefore 19 by 4 is multiplied with the x is 19 divided by 4 x. So plus into minus is minus, and here 19 by 4 into 1 by 2 means it is 19 by 8. It is 19 by 8. Now subtraction. Think that this process will continue here only. So okay. So here changes. Okay. So here it is minus and here it is plus. So automatically this cancelled out. What left now? 1 plus 19 by 8. 1 plus 19 by 8. It means there is no other variables. Means it is less than the divisor. So the remainder you multiply it becomes 27 by 8. So your last remainder means r of x equal to this much. Through this expression, consider that q of x is equal to x square plus 7 by 2x. Okay, plus 19 by 4, and the remainder x is equal to 27 by 8. So this is our required solution. P of x, g of x, q of x and r of x. Suppose you want to check it, use the same general form. P of x equal to g of x, q of x plus r of x. Then automatically verify the result. The result is equal to dividend of this expression and the right side. Means left hand side and right hand side must be equal out. So this is. Now take the same expressions of the next one. X cube plus 3x square plus 3x plus 1. Consider this p of x. Okay. Now g of x equal to, so that is x plus 5. X plus 5 means I took the fourth one in the first line. Now by division process. Okay, by long division. Okay, by long division. So in which you can write x cube plus 3x square plus 3x plus 1. So take this one x plus 5. X plus 5. Take the first term of the quotient, which will be equal to x square, because x square into x is x square into x is x cube. Okay. So here plus 5x square. 5 means any, you know that already it is a irrational number on real number set. So here it is become minus, here it is become minus. So this is cancelled out. What left now? 3 minus 5 into x square plus 3x. So now take the next term, which is equal to this one. That is 3 minus 5 is compulsory. 1 you should refer under x. Here it is x. So that is 3 minus 5 into x square. Because 3 minus 5 into x is x. 3 minus 5 into x into x is 3 minus 5 into x square. So the next plus here. Here also plus into plus plus. Consider this sign also. 5 into 3, 5, 5 means 3, 5, okay, plus into minus, minus 5 square into x. This is. Now on subtraction, this become minus and this become minus. Okay, so this is eliminating, and the next term, that is 3, okay, 3 minus half, 3, 5 minus 5 square, okay, minus 5 square, x is common. So look here, suppose you want to open the bracket, it becomes 3 minus 3, 5 minus 5 square into x. So which term now? Here it is less than that or equal to that one. If you multiply, you can get the same answers. So here, so 5 square means highest degree is 2. Here 1 means it is also one real number. So no consider variable. 3 and 5 are also any real numbers or integers. Okay. So only consider the x variable. So in order to eliminating the x value, it becomes plus 1 because x into 1. Consider x into 1x, it becomes x, but it is also one number. So in order to avoid that, you can take the same term of into 1 minus 5 square. So this is now. If you multiply this to this one, you will get answer is like this. Last answer 3 minus 3 5 minus 5 square into x. Okay, plus 5 into this much. 3 minus 3 5 minus 5 square. Hope you getting the idea. So this, in order to avoiding this term, it is reduced to this equation. So in order to eliminating this expression, it should be multiplied the same term. Means this dividend of the first term, that is coefficient of the x variable, is multiplied the divisor the same term. So when you multiply this and this, you will get the first term as like this. So on subtraction. Okay, on subtraction this become minus and it become also minus. So therefore this will be cancelled out. What left now? There is no other variable. Here this variable, it is less than that. So that is why your remainder must be equal to minus of 5 into 3 of 3 5 minus 5 square. Otherwise simplify it, you will get minus 5 minus 3 5 plus 3 5 square plus 5 cube. So that is why it becomes 5 cube plus 3 5 square minus 3 5. So otherwise 5 square plus 3 5 minus 3 into 5. Here what I done? I just multiply this and this. I will take the common factor. So 5 into 3 is 3 5 plus into minus into minus plus. So in order to avoid this one, so I took their standard form. So that is why this become 5 cube will be written in the first term, second 3 5 square minus 3 5. So we can take the common as 5. So for all this, now what is the remainder? 5 square plus 3 5 minus 3. So the same way you can check the result in the general form. You will get easily the same expression along with the left hand side and the right hand side. So this is the remainder of this example. So dear students, in this class we studied the whole concept about the remainder theorem and its examples, exercise problems. Left of the two problems are there, so you can find the solutions of the two examples. Okay, thank you.